start here, I got the right-hand rule in effect. Travel up here and take a right-hand turn, take a U-turn, a right-hand turn, and get back to here. And we notice after we ended, and remember we have a right, U, right. And we have a rule in there, so if we see a R, U, R, we change that to an S. Now what if we had this at the end? Right, right, straight. So I don't see a U in there anywhere. So it's not going to reduce that. But we treat this as an XY coordinate system. We call that north, south, east, west. Then we have a X odometer, and it increments positive when we go east, and decrements negative when we go west. The Y odometer, which is positive when we go north and negative when we go south. In addition to those two odometers, I've got a variable that tells me which direction I'm going in. They can take on any of the four values. North, south, east, and west. So whenever I encounter an intersection, I zero out the X and Y odometers and assume I'm going north. So here's an intersection. So I'm going north, well, I'm sorry, after the turn, I'm going north. It's like south. And my going south, so I decrement my Y odometer. So it's minus 10 inches. And then I'm going east, and I turn. So now I'm going east. So I no longer mess with my Y odometer, I mess with my X odometer. So I increment that, and it goes X is 10 and 0. And then over here we've got minus 10 and 10. And then we turn left, so we're going north. And that increments our Y odometer, so it gets back to 0 at this point. And likewise, when we get back here, we make this turn and we switch over to the Y odometer again, or the X odometer. And it was at 10, but we're going in the opposite direction, so it decrements down to 0. So we got 0, 0. When we get to the next intersection, this is intersection encounter number 1. These guys don't count as intersections because you only go one way. So lo and behold, we got a 0, 0. What does that mean? We're back at the same place we were. We've gone through 2 consecutive intersections, but we didn't go anywhere. Gee, that must be a U-turn equivalent. So I mark it as an N for noose. So we go R, do our thing, and then we check to see if we got a 0, 0 here. If we do, we insert an N for our S. So I got an RNS here. Right turn, 0, 0 means noose, and straight, RNS. So RNS we reduce to U. And then the algorithm says that's a U, so we got R, which is straight. Good. That's how I did it. Now this will not work, it will absolutely fail. If you've got another dead end hanging out here somewhere, I forget which way it goes. Let's see, right. Left. Okay, so right turn rule going along here. We don't want to go left, we want to go there, so that's a U-turn. So we've got straight U right. Straight U right. So we eliminate the straight U right, continue on. So our odometer started here zeroing out, got to here and said that's not an N. So we didn't insert an N anywhere. So I've got no way of knowing that there was a noose there after the fact. So it'll get rid of that, but it won't get rid of that. So if you had any structures like that, it would not reduce that. think I'd probably have to remember the coordinates of every single intersection encountered and somehow work backwards to